Team, it's Mr. Z, and today we're going to explore patterns in odd and even power functions. All right, so essentially we're taking our graph from last time and we're going to categorize it. Basically, the inputs are on the left, x, and we've put our odd degrees, x to the first, x to the third, and x to the fifth, and then we've separated our even degrees, x squared, x to the fourth, and x to the sixth. We're going to go ahead and analyze some of the behaviors we're noticing. And for the first thing is between -1 and 1. So I don't want actually to include -1 and 1, but I want to compare this region. What do we notice about the outputs? Between -1 and 1, the outputs are all fractions. Smaller than 1. How does this change compare with the values that are less? So this is between -1 and 1. We want to look at the values less than -1 and greater than. And notice here, the numbers start to get bigger. For the values less than -1 and greater than 1, the outputs grow exponentially. Essentially, once I start putting in bigger numbers, when I put in 2, notice how the numbers start to explode, starts to grow. Well, where before the numbers are all fractions in between -1 and 1. Positive or negative, they were all very small and are close to 0, either on the left side or on the right side. Now I want us to observe the behavior of each graph on either side of 0. Now this syntax might be a little different, but think about it. 0. On the left side are negatives. On the right side are positives. Same thing here. And we're going to have to look at it for both of them. We're going to have to look at even and odd and see if we can draw some conclusions. So for negatives, what you might notice for the odds is, let's go ahead and erase. So we're only looking at odds. And what happens when I plug in negatives? It only turns to be negative outputs. What about for the right side of 0, for positives? Notice how they're only positive outputs? So, for odd degrees, the negative values have negative outputs. Here, positive outputs. This creates the graph. If I'm just trying to sketch an odd degree, it's going to look something going from a negative output to 0 and then becoming a positive output. Likewise, I look at the same chart. I am looking at evens now. Let's look at the negative values. Here they're positive. Let's look at the positive values. All the outputs are positive. This lets me sketch the generic rule for a even degree. Positive outputs, and then it goes to 0. Positive outputs again. Voila. Okay, for 3, both the odd and even degree functions. Explain why the graphs flatten as the degrees increase for the values between -1 and 1. Fractional inputs less than 1 produce fractional outputs. For example, if I have x is equal to 1/2 when f of x is equal to x to the third, this means when f of 1/2 is going to be equal to 1/8, which is actually less than the original amount. Whole number inputs greater than 1 produce large outputs. For example, when x is 1, when f of x is equal to x to the third, it means that the output would just be 1. When it's 2, when f of x is equal to x to the third, that means f of 2 is going to be 8. And likewise, for the same function, when x is 3, it's going to produce 27, and it's only going to get bigger from there. I've only done the first 3 numbers, but you can tell that it is exponentially increasing.